Hello guys, this is your boy. Effects of changing components in a circuit. At the end of this video, you will be able to identify the two types of electric circuit, series and parallel. Determine the effects of changing the number or type of components in a circuit. Why do bulbs produce different brightness? What factors influences such brightness? If you have observed the bulbs in your home, you may probably wonder why. First, your parents do not want to buy light bulbs having high wattage because, according to them, they have to pay so much electricity. For instance, instead of buying 10 watts for big room, they prefer to buy 3 or 5 watts. It doesn't mean that they do not want brighter light bulbs. The truth is, brighter light bulbs consume more electrical energy than dimmer light bulbs. So, they prefer dimmer lights. If you have to choose and suggest to your parents, would you rather have a brighter bulb or a dimmer one? As a student, maybe you will choose a brighter light bulb in your study and a dimmer light bulb when you sleep. When you switch on the light bulb, that means you close the circuit. And when you switch off the light bulb, it means you open the circuit. A simple electrical circuit contains 4 parts: the power source, which is usually a battery; a load, which is usually a simple light bulb; a connector or wires, usually made of copper or aluminum; and switch, which is a device that can open or close the circuit without having to disconnect wires from any component. Simple circuit. An electric circuit is a complete conducting path for an electric current. When the circuit is connected to a battery, electrons flow from the negative terminal of the battery through one or more electrical devices and then back to the positive terminal of the battery. Some conductors allow the current to flow, usually in opposite direction, through the circuit. Depends upon the number of electrons flowing through the circuit per second. Each device placed within the circuit provides a resistance to the electrons flowing through the wire. Some devices apply greater resistance than others. Battery or house AC outlet is a source of electrical energy. Load, a device that consumes electrical energy. Switch, a device that stops or continues the flow of electrons. Connector, a wire that transports electrical energy. What are the 4 parts of simple electrical circuit? 1. Power source. The power source provides energy so that electricity can travel along the circuit. It can be battery or an electrical outlet in a house, depending on the voltage requirements. The function of the power source is to provide energy to the electrons so that they can move in the circuit load. Number 2. A load. The load is any device that draws power, such as simple light bulb, electric fan, and electric drill. Number 3. Connectors. Connectors are the wires usually made of copper or aluminum. Their function is to transfer electrical current efficiently. Number 4. A switch. The switch is a device that can open or close the circuit without having to disconnect wires from any component. If the switch is open, the electrons cannot move, so no appliances get power. Effect of changing the number or types of components of a simple electrical circuit. So what happens when we change number of components, or if we change the type of components? Would it affect the brightness of the bulb? A. Changing the type of battery in the circuit will change the brightness of the bulb. This is because battery is a source of energy which provides energy for the current to flow in a circuit. When the energy in the battery is used up, there is no current anymore and the bulb does not light up. If another full battery is used, the current increases and the bulb becomes brighter. B. Changing the batteries with different voltage will also change the brightness of the bulb. If the voltage is too low, then the bulb will not light. If a larger 6 volts battery is used, the rated 12 volts bulb would have a dimmer light. But if a 12 volts battery is used, the rated 12 volts bulb will become brighter. C. Changing the type of bulb having different wattage will also change its brightness. Well, it is simple. The watts determine the brightness. Watts is the unit of power, and power is equal to voltage times the current. So in effect, both the current and voltage determine the brightness. Different bulbs with different watts have different brightness. A higher watts means a brighter bulb, and a lower watts means a dimmer bulb. D. Adding the number of bulbs will also increase the brightness. On the other hand, subtracting the number of bulbs will produce a dimmer light. The number and types of bulbs also affect brightness in a circuit. Two kinds of circuit. 1. Series circuit. A circuit that has only one path of electricity, where all the bulbs are connected one after the other in one chain. The electric current flows through a single path. So when one bulb is loosened or busted, all the other bulbs in this circuit will not light anymore. The loosened or busted bulb breaks or opens the pathway, so electricity cannot flow through. Series circuit has only one switch that controls the flow of electricity. Effect of changing the number of bulbs in series connection. As the number of devices placed within one series circuit increases, the resistance also increases. Increasing the number of bulbs in a series circuit decreases the brightness of the bulbs. In a series circuit, the voltage is equally distributed among all of the bulbs. If any series bulb is unscrewed, an open circuit is created and no current exists. Number 2. Parallel circuit. It is a circuit that has more one path of electricity, that has light bulbs with different loops. Each bulb is part of a different circuit. When one bulb is loosened, taken or burned, the other bulbs still light up. This is because each bulb has its own pathway. A break in one pathway does not make all the lights go out because electricity can still flow through the other pathways. Effects of changing the number of bulbs in parallel connection. In parallel connection or circuit, as electrical devices are added or increases, the resistance decreases. Bulbs in parallel are brighter than bulbs in series. In parallel circuit, the voltage for each bulb is the same as the voltage in the other circuit. Unscrewing one bulb has no effect on the other bulb. Effects of changing the number of batteries. Effects of changing the number of batteries in series connection. Increasing the number of cells or battery connected in series will increase the voltage without changing the current. Increasing the voltage also increases the brightness of the bulb. Decreasing the number of cells or battery connected in series decreases the brightness of the bulb. Effects of changing the number of batteries in parallel connection. Increasing the number of cells or battery in parallel connection increases the current without changing the voltage. An increase in current without changing the voltage has no effect on the brightness of bulb if the voltage is still the same as it was. We can only see the difference if we will use drained batteries and compare it with fully charged batteries. Used up batteries have low current, and this will affect the brightness of bulb. E. Changing the length and diameter of wires will change the brightness of the bulb. First, the total length of wires will affect amount of resistance. The longer the wire, the more resistance there will be. Resistance is the hindrance to the flow of charge. This means that the light will go dimmer if there is an increase in resistance. Second, wider wires have a greater cross-sectional area. The wider the wire, the less resistance that there will be to the flow of electric charge. So this means that lesser resistance will result in brighter bulbs. If changing the type of wire will also result in brightness of the bulb, because not all materials have the same conductive ability. Silver is one of the best conductors, but it is not usually in circuits because it is expensive. Instead, copper and aluminum is used in high-tension grid lines because they are among the least expensive materials. List of materials arranged according to the conductive order. Assuming they have the same size, Pure silver is the most conductive, while stainless steel is the least conductive. Thanks for watching, and once again, this is Sir Boyet. Keep on watching and learn something on my channel. Please subscribe for more video updates. Thank you.